one of those things is true, then we have a parallelogram. So, if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Okay? Are you going to really side converse through this entire thing? Okay. Focus. You are now on YouTube being yelled at. Okay. So both pairs of opposite sides of a quadrilateral are congruent, then we have a parallelogram. If both pairs of opposite angles are congruent, then we have a parallelogram. Right? These were just theorems about parallelograms that we talked about yesterday. If the diagonals bisect each other, then it's a parallelogram. And then this is the only one that is new-ish, is this last one. This last one says if we just have one pair of opposite sides, and we know that that one pair is both parallel and congruent, then it's a parallelogram.
So like all those.
So like this. So here's a parallelogram, or here's a quadrilateral, and if we know that this opposite sides are congruent and parallel, then it's a parallelogram.
So if we know it's on.
Like it's given to you like this, then we can say yes, it's a parallelogram. That's the only one that's really different than the parallelogram theorems that we talked about yesterday. So, determine whether quadrilaterals are parallelograms. Justify your answer. Justifying your answer is letting us know which of these ones up here it qualifies as. So number one, there's our quadrilateral. It has the side lengths of 20, 35, 20, and 35.
8.12.
Is this a parallelogram? Why?
8.12 is
Well,
opposite side.
Okay. Yep, we're not going to say 8.12 because 8.12 doesn't really mean anything. Just some number that the book company decided to write it as. So instead, we're going to say yes. And why do we know it's a yes?
Opposite sides of quadrilateral are parallel.
Oh, we don't know anything about parallel, though, do we?
We just know the opposite sides are congruent.
We just know the opposite sides are congruent. So yes, both pairs, opposite sides are congruent. You can abbreviate to your heart's content as long as it makes sense. What makes it a parallelogram?
Yeah.
The opposite sides are congruent. The opposite sides are parallel. The diagonals bisect each other. The opposite angles are equal. Consecutive angles are supplementary. Did you get all that?
Yeah, I got it.
Okay. Next one, 2. Why is or is this not a parallelogram? Yeah, so yes, this is. Opposite angles congruent. Okay, because the opposite angles are congruent, we know we have a parallelogram. Are those 2 examples okay? So here we want to find x and y so that each quadrilateral is a parallelogram. So we need to make the equation such that we would have some true things for parallelograms here. Yeah, so for 3, these sides are opposite of each other, so we would just have to set them equal to each other. So we'd say, okay, 4x minus 1 should equal,
3x plus 6.
good, 3x plus 6. So minus 3x, add the 1, yep, so x is 7. What else would we have to have on here so that this is actually a parallelogram?
That's fine. I think I'm these ones in there saying 8.9 and 8.9
Okay,
Which one? What was 8.9?
I don't know. I'll get it after. Okay. Does that make sense? Now what else? If here we just have one sides being opposite that are equal. In order for this to really be a parallelogram, we would have to know that those 2 sides are also equal. We're not specifically asked to tell that, but we should know that.
So like, if those two, then those would obviously be?
No, I'm just saying that they'd have to be for this to really be a parallelogram. All right, number 4. How would I solve for y if this is a parallelogram?
You set them equal to each other.
Set them equal to each other. So 5y plus 28 is equal to 6y plus 14. So how do we solve this?
Y equals 14.
Yeah, minus 5y minus 14. So y is 14. Now, would that alone make this a parallelogram?
The tops would have to be.
Well, in this case, the opposite angles would also have had to have been congruent to each other. Okay, number 5, we've got ST is 2y plus 11, QT is 5y, PT is 5x minus 28, and TR is x. Okay, so we should label it first. So ST, 2y plus 12. QT is 5y. PT is 5x minus 28, and TR is x.
So wouldn't you do 2y plus 12 equals 5y?
Yes, 2y plus 12 should equal 5y. Why?
Because the opposite.
Yeah, the diagonals bisect each other, so the diagonals should be congruent to each other or they bisect. So 2y plus 12 is equal to 5y, so how would we solve this? Yeah, so subtract the 2y, so we get 12 is 3y, so our y is 4.
And would you have to set 5x minus 28 equal to x?
Yep, and then 5x minus 28 should equal x. So what does negative 28 equal?
7.
Negative 4x, yep. So x is 7. It's clearly getting too close down there. The screens kept popping up. Is that okay?
Wait, you would subtract the 5. Or
You can
could you
do
do
it-
it the other way too?
yeah.
Oh, yeah, you can do it the other way.
I did.
It doesn't matter which way. Is that okay? Okay. So now there are going to be 3 methods that we can use to say whether or not we have a parallelogram. I did not give you graph paper on there. So I gave you 1. Okay. That's good. All right. So I'm just going to talk about the 3 methods and how you use them. So we're going to do one example with each other, and we'll discuss the 3 different ways and how to use them. Okay? Instead of doing 3 examples. Is that okay? All right, so I want to decide if this is a parallelogram, and I want to use the indicated method. I included a graph for those of you who are visual and who need to see the graphs. Okay, so if you're a person who needs to see the graph, plot those points. All right, so A here is at negative 3, 0. B is at negative 3, 1. C is at 3, 2. And D is at 1, negative 1.
Were you just going to do all 4 or all 3?
Yeah, we're going to talk about all 3 ways with this one. Okay, so this would be determine whether or not it's a parallelogram using the slope. So tell me what you know about slopes and parallelograms. Okay, tell me what you know about parallel lines and slopes. Yes, parallel lines have the same slope. So which lines on here should have the same slope? Okay, so well, we need 2 letters for a line. So DC and what one should have the same slope as? And AB should have the same slope. And then AD and BC should have the same slope. So when we do the slope method, we're going to find those slopes and see if they're the same. You could do this a few different ways. You could use the slope formula. Or if you like to plot the graphs, what's your other option you can do? Could you just count the slope? So if you have it plotted, you can certainly just count the slope. If you want to just look at the points, you just plug it into your slope formula. So let's count the slope. So counting the slope from D to C. So D, how much your rise here is? What are we rising? 1, 2, 3. You run 2. So the slope from D to C is 3 over 2. What's the slope from A to B? 1, 2, 3, and over 2, so 3 to 2. So far, so good. We got this set of parallel lines. Let's check the other one. A to D. So down 1, and then 1, 2, 3. Negative 1/4. We went down 1, we went to the right 4. And then BC, down 1, 1, 2, 3, 4. Over 4, so negative 1/4. Yeah, so these are parallel, these are parallel. So yes, it's a parallelogram. Is that okay for the slope method? Second method, distance method.
So can we cross out problem 7 and 8?
Yeah, we'll just talk about it all with this one. Unless I run out of space, then we might talk about it with another one. Okay, so distance method. What can you tell me about the opposite sides? They have to have the same distance. So DC and AB should have the same distance. And then AD and BC should have the same distance. So what formula do we use for distance?
Square root of x plus the square root of
The distance is the square root of the change of x squared plus the change of y squared. Or for those of you who didn't like the changes of the x2 minus x1 squared plus y2 minus y1 squared.
I forgot how to do the changes.
Well, we'll go through it right now. So from D to C, so let's look up here. This is usually easier to look at from your points than from the graph. So from D to C, how much do your x's change? From 3 to 2. Or sorry, 3 to 1. They change 2. So you have square root of 2 squared plus, how much do your y's change from 2 to negative 1? 3 squared. So what's 2 squared? 3 squared. 9 and 4 is 13. So DC is the square root of 13. Okay, A to B. So from A to B, how much do your x's change? 2. How much do your y's change? So what will 2 squared plus 3 squared be? So that's also the square root of 13. Those are equal. Now what would we have to do with the other set of sides? Same thing. So from A to D, negative 3 to 1 is 4. 4 squared plus 0 to negative 1 is 1 squared. So 16 plus 1 is 17, square root of 17. And then B to C. B to C, so we change 4 and 1, which would also be the square root of 17, which are equal to each other. So that's how we would show that it's a parallelogram. If they're not equal, would it be a parallelogram? Okay, and then the third method